Hey, Mark. Hey, Rudy.
Hello, James. How are you today?
Not bad.
Hello.
You.
Yep.
Hey, Kendall. It's nice to. Oh, I think it's connecting on audio. Hey, Kendall.
Hi.
It's nice to have you back. I haven't seen you for some times.
Yeah, I've been out for a few.
Oh, okay. While waiting for others to join, and let me start. Just start sharing my screen for now. Let me see. Where's the ADK? No, not this one. ADK. You'll probably get a few more minutes for others to join.
Okay.
Hey, Jawan.
Yeah, hello, Joanne.
Hey guys, sorry, couldn't unmute.
Yeah, we're kind of expecting that. Hey, Tony.
Hey, James, how are you?
Good, good.
Hello, Tony.
Hello, Mark. How are you?
I'm doing well. How are you?
Busy,
Okay.
but good. Thank you.
Mhm.
We probably maybe give a few more minutes for others to join in. So
So, James, I didn't hear back from Satish. Have you heard from Chris?
no, I sent to both Satish and Chris in the same email, but I don't hear back from them. I may have to kind of dig into and see, trying to find the number and call them.
All right, I don't know if I have Chris's number.
um,
Do you have his phone number? I can call Satish, but
let me see. I can find Chris' number if I have it. Okay, we see. Hey, Pratyush. So you can find his number here.
Yeah. Hey, James. Hey, Tim.
Hey, yeah, I can hear you now. Good. I have some email exchange. I think I will Chris sometimes back and just see if his number is there in the email. Yeah, we have more people. I think we just like Tony and I am just trying to see if we can reach people from Intel studies. So Chris, that which last time they mentioned there will be available, I think, to present the ADK, the assembly design rules from the Intel. So and last time I think when we talked about before end of the last year, and then we were talking about early this year. So hopefully maybe like the after like the first meeting, I think a second meeting when they right most likely will be back by the time. So that's why we're trying to reach out to them, but we're trying to see if we can reach out to them. I haven't found his number yet. Well, meanwhile, some other people here, excuse me, other update is like as I think from last meeting, we kind of like concurrently talk also about Sadis Intel, I think for presentation or Chris, I think for the for the assembly rules. At the same time, we also like talking with the ASE, talk to Roger, I think, about getting the assembly rules from the ASE side. So they say last time here is that they working with the fab or the manufacturing in the Taiwan, and trying to work with the team there and trying to get some more generic assembly rules, not customer proprietary information, to be able to share here for the kind of open standard definition. So I think, yeah, Roger, and last time he mentioned, I think that he will be traveling to Taiwan, I think for January. So it seems like he hasn't back yet. So I pinged him. I've been he will likely back at end of the January. So meanwhile, probably not getting, I think a good response. I think responding. I think as we expecting. I think why he's traveling. I think for the business there. So and then we also talked to the Angel, I think from the HRL, I think to be able to share the perspective from the consumer side, the end user side. So we were talking to Angel would be able, I think mentioned, will be able to share and present information from the HRL. And then but Angel, I think I just kind of feel, I think they will need more, I think time, I think information, and also information to better share this or what they intended to. So I think they was kind of requesting to do this in the next meeting, to have more time, I think to prepare for that. Is that correct, Angel? I just saw you are coming up.
Yeah,
it's nice to have you to join.
Yeah, James, thank you so much. What I was thinking, I have one slide. I wanted to show you like an overview, and maybe then we can discuss if this is what you were thinking. And then for the next one, if a little bit more in depth, we can go over. So maybe it's a good idea we spend 5 minutes at the end if you want, or maybe 7, and we can go over what we had in mind, if that's okay. Yeah, I have one slide I can share.
Oh, yeah, absolutely. Feel free to share that. I think this is an open forum. I think it's very open discussion. It's good to have that. I think to really for everyone to view. I think that's the right direction there. Yeah, I think that's a good idea. I think let's go and do that then. So I'm probably going to stop sharing here, and so that you can start sharing.
Sounds good.
Yeah. Go ahead.
Excellent. So let's see. Share screen.
Yeah, it's
yes. Do you see my screen?
I think it's coming up. Give a second. Yeah, now we can see it. It's
okay.
Good.
Okay, great. Do you see? Yeah. Okay. So basically, I wanted to just, I don't know how familiar you all are with the traditional gallium arsenide, gallium nitride, traditional two metal level process. So it's interesting. So this is a kind of a probably 40, ancient to 40, certainly over 30-year-old technology. However, it's still used in millimeter wave designs. It has some strengths, some weaknesses, but I think not just for what it is now, as far as what the rules are now, what the dimensions are for the different say for the different components that we have for the mimic, but I guess also looking into the future sort of thing. How is this evolving, right? So basically, as you know, the heart of the process is the HEMT, right? Whether it's or a p-HEMT, right? If it's gallium arsenide, the HEMT device has a lot higher mobility than silicon, a lot higher breakdown. So basically, the same or higher FT, with a lot more breakdown, which of course is beneficial for power amplifier applications. There's also very good low noise, so we have a lot of switch essentially RF front end applications here. Now, so that's like kind of a snapshot of what a. Let me see. Why can I? Oh, I see here. Yeah. So that's kind of a snapshot up front. So you can see a top-down SEM of what a device looks like, right? Gate header might be in the order of hundreds of nanometers, and typically one of the, I guess, strength and weaknesses is heavily gold based, so gold metallization based, and air bridge based, right? So as far as the mimic, it involves through substrate vias, air bridges, of course, source drain connections to the HEMT, and then transmission lines, TFRs, and sometimes epi resistors, and that's kind of that's pretty much it. It's quite a simple from the point of view if you compare it to, say, an ILD process that or silicon backend. But I think what we care about are the dimensions and the rules. So basically, some of the main rules are the TSV processes are hard in general, so we require sort of there are rules that are required that will avoid or prevent designers from placing the wrong objects directly on top of the via. So those are kind of easy, easy rules there. But then you have your traditional spacing and also spacing overlap and inclusion. Because of the simplicity of the process, we do have. I think we like the idea of having these pre-made sort of P-cell style objects that we can scale, and those are kind of what we call metal stacks. So if you have two metals, you can have a transmission line with just a metal layer, maybe two, maybe this overlay plus M1, or you can have M1 and M2, like this plated gold and M1 here. So now the dimension ranges are here. This is not to say that we're not actively looking into improving this substantially through, even DARPA's invested in this. The question is, well, granted you have a higher mobility, or rather, higher mobility at higher breakdown, you have this capability. What if you had a copper damascene or like a better backend? Where would that take you? So there are definitely pushes to make these dimensions more scaled. And that's something that we would imagine we have to take into account, kind of the future, right? That's the point of kind of setting a standard. Is it's not just good for what we have today, but 10 years down the road, does it accommodate what we need?
Right. Andrea, could you explain what the air bridge does, or the feature itself?
Oh, absolutely. So, and this is kind of an unfortunate. Twofold unfortunate here. I'm only showing you 2-finger, but if I show you a 4-finger device, right? Right, then to join the sources that are in the middle. So basically, if you have 4, then we use the air bridge primarily for that. So the air bridge is it's mainly used.
So it's like a comb, and the tooth of the comb are touching all the source regions. Is what you're saying?
Exactly. So basically, this device right here only has M1. So if I wanted to put M2, right, so that I want to connect the sources on wafer, so then yes, I would put this air bridge that jumps over this the drain, basically. Exactly. So that's
I see. Carry on, please. probably.
Oh yeah,
dig
no, I was
deeper
just gonna
later.
say
Yeah.
you can do this with an ILD layer, but unfortunately the we also want to avoid the parasitic, so it's kind of a nice
I see. Yeah.
yeah, right, to kind of try to
That was my question gonna be. Yeah, thank you. Yeah.
yeah. So sorry, that was pretty brief, but I mean, basically, we would look into expanding on these, kind of adding more details. They're extremely similar to what you already have put forth. Maybe there's a couple more that are a little bit more involved that we can touch in the future. I'm hoping. So yeah, that's all I have. Let me know if this sounds kind of towards what you're aiming, and then we can expand on kind of this table.
I have a couple of questions on this one.
Mhm.
So, what kind of design tools are common in doing this system design?
Yes, so for this mimic design, I wouldn't say over 90, yes, a huge percentage of the community uses either a Microsoft Office AWR or a Keysight ADS. Then there's also a way to handshake this with Cadence, which is I would say the least of the folks that do this traditional millimeter wave design.
Okay, so if for AWR and ADS, do these tools today support some kind of a assembly design rule input?
Yes, in fact, that is a very current question. We just got Keysight to add another rule definition, say function, I guess, function to their decks. So yes, we are able to do a decent job with Keysight ADS with AWR. It's not as good as Ashura, unfortunately. So the answer is it's typically more stringent, actually, the error on the side of caution, which is good. So basically, from our end, as a foundry, we have to tell people, yes, you can use it as a guidelines, but careful, examine the output, etc. So yes, the answer is partially. What we get from the EDA vendors is that they're trying to refine this to make it, kind of as good as Ashura, like gold standard here. But yeah, it generally, for the most part, they're fairly decent, at least to provide enough guidelines so that you can carry on with your design. Absolutely.
Okay, so Ashura mostly works on design rule checking,
Yes.
which is primarily going to be design rules of this particular substrate, silicon carbide, and all of that, right?
Yes.
But when you were thinking about the assembly, that, after you have this component ready and you want to place another component on the other side, are you envisioning any need for a next level design rule that may be related to assembly of components?
Absolutely. So the chiplet, so the chiplet to chiplet rules. Yes, if we were to, and in fact, this is an ongoing kind of project. If we're to package these across in close proximity to other chips, we need to do 3D, FEM analysis for radiation and other effects for coupling. Absolutely, and this is something, in fact, we just apparently ADS is supporting this, actually, and so we're looking into how to incorporate that into our flows. Of course, it's as a foundry, you can't really impose. You're well, it benefits us to support as many EDA vendors as we can, obviously, for obvious reasons. But yes, there are some clear voids there, actually, as to how to merge a PDK into an ADK, rather. So basically, within your full, say, interposer or whatever packaging advanced packaging environment. Absolutely.
Okay, so can you help us understand that for the assembly piece, typically how many parameters do these rule sets carry?
How many Oh, okay. Yes. So basically, do you mean at the mimic level or within the 3D HI or
No,
3D
I'm thinking assembly of components.
assembly? Yes. Okay. So assembly of components at that point, see, so part of the issue answering that is that right now is very segmented, right? Right now you almost have the layout folks not quite in sync with with the, say, the full system simulation folks, let's put it that way, or even the tools themselves, right? So it's not ideal. And as far as parameters, so typically it's kind of a painful back and forth, meaning you start off by defining, say, your pad pinout or your pad outline, and your obviously your chip and pad outline. You may have some keep out regions that just based on rule of thumb or prior failures or successes. So it's not very large right now, and it's part of the problem as to why the design cycle is not optimal, basically. So yeah, that would be a definitely room for improvement there. How
Okay,
to
Sounds like
yeah.
sounds like an opportunity.
exactly opportunity. That's it. That's the word. And we're
Yeah,
eager.
Yeah,
We're
I want
eager
to throw in
test
there that
out. Go ahead. Yeah.
I wanted to just add that Siemens also is looking at with our Tanner custom IC toolset. We have some work with Keysight to integrate ADS and Caliber for the rule checks and Tanner for the design environment itself. So something to just be aware of. You didn't mention our tools.
Yes.
So
So actually, so for the EDA guys, we would be thrilled and very happy to. I mean, I understand you can't put out roadmaps. Most folks, it's kind of proprietary stuff, but basically, at least having this dialogue of things that would enable kind of what we need, that would be awesome to have maybe a list there or some sort of, I don't know how a clean, a scrub version that can be made public, right? This kind of overall goals of this kind of next generation code design. Yeah, that would be a great use of this platform.
Yeah, so one thing that I think this is helping me to see is that it seems like there's not very much of a clear boundary between assembly design rules that you're dealing with for package assembly and silicon design rules, or gallium arsenide in your case design rules that you may get from a foundry in traditional PDK. And in fact, you were even talking about merging PDK info into the assembly.
Exactly. What we think that the secret, well, but maybe part of the real challenge will be is understanding from the packaging point of view, how do we feed into the ADK the information as far as what's mechanically, what has mechanical integrity, mechanical integrity versus what doesn't. I think that because you can do things from the dimension point of view, but then the mechanical side is such a unknown territory for these that really relies on trial and error, that is quite unfortunate, and it's quite underdeveloped, honestly, as we look at the entire what are the bottlenecks here. The rules themselves, I don't think that's the hard part. I think that the hard part is to understand, depending on the materials that you're dealing with, how to apply those rules, how to narrow them up, how to narrow them for what application, etc. I don't know if you feel that way from your experience.
I think that's absolutely the big opportunity or the challenge, right, that we try to solve. So one thing we all are interested in defining some of the formats to help each other in terms of, a common set of rules that can be used for design and assembly. So I'm super interested in learning from you, what are your specific pain points in that area?
Yes. So let's absolutely. That is step one. Basically, how do we put together? Yes. How do we get all these different PDKs and interposers, right, etc., to talk to each other in an efficient manner? Absolutely.
Have you got an example of a PDK? And if you don't want to share the proprietary rule values, just put in some dummy rule values. But do you have a sample PDK file that you can share with us?
Yeah, I mean, so that's the thing. I'm not sure. So for instance, if you were one of our Foundry customers, you would get the booklet under NDA. So I wonder if does this group have like a multi-way NDA or?
No, we are an open public group,
Oh,
so
that's right.
so if
Right,
you
yeah,
if
go
you
ahead.
need to share, it's one-on-one.
Got it. So let me, yes, I think there's enough open, and I think just dig into the right place. There's enough information out there, especially for some of the legacy processes that might have, migrated. Not to say that they're not representative, that I can probably dig that. You basically you're asking about a full set of rules, like an example
Yeah.
of. Okay, yes. Let me make a note on that.
At least you need an example of one rule for every rule type.
Yes. Oh yeah. I think that, and see how does this work? What if we were to give you let's see. Yes, let me look into that. Yeah. I think that should be doable without
I would
get
assume that the IP is the rule values. So if
right.
you just eliminate all the rule values and replace it with one single value all the way through, or just an example value, it would it would be sufficient for us.
Yes, I understood. Yeah, that makes sense. Yeah, let me make a note on that. So let's see. I guess I have to exit this. How do I do that? Let me make a note so that I'll share. Oh, there you go. Yeah, let me sorry, I just kind of try to get control of my here to make a note. Yes, and then I think probably, hopefully in 2 weeks I can give you a better update. But I will definitely, yes, I can definitely get back to you on that. Yeah, I'm making a note of that. Yeah, thanks so much for the feedback.
Got it. So, like, Angela, so your focus is on this, like, silicon carbide kind of a wafer. Is that correct? I mean, like.
So yeah, that's interesting. So silicon carbide, we've done sapphire, silicon. It's not completely. I think what the difficulty here is that the through substrate via, right?
Yes.
But yeah, it can be even gallium arsenide as well, or even indium phosphide. So this can be a variety of materials. Yeah.
Okay. So and then your area of focus is mainly around this wafer area there. The process for the wafer, like creating these wafers and then kind of like building wafers features such as like via, and then that can be used for this kind of like 3D integration and things like that.
Yeah, so that's one area exactly, and then the second area, equally important, or depending on the application even more, is how to integrate this efficiently and effectively in a bigger, multi-chiplet system or interposer system. Absolutely, that's also part of our focus as well. Yeah.
Got it. So I think there will be a rules around this kind of like integration, right? Because
Exactly.
this subject is a different kind of like you need assembly for that one, right? To put them together, and then that's why you need this kind of rules, kind of like help. I think it sounds like you might have different entities like assemble, help to put them together. They will have this kind of based on what machinery is that can capable to do. Then we have to define those rules, to make sure they kind of like able
Exactly.
to do what we intended here. I think that's part of this standard format R4. I think I putting a standard kind of rules, kind of like interoperate parties can kind of work together based on these rules. That kind of like in a format kind of everyone agree on, and that kind of facilitates the industry to exchange the information and the data.
Exactly. You're right. Basically, kind of distilling or making sure all the rules talk in the same language, basically, right? Can we narrow down the number of functions that we need, make it efficient, yet encompass everything we need? Absolutely. That makes sense.
That sounds good. So I think when with that example, I think that we have some of this rule, I think a process, including some of this kind of like the what I just shared there, I think and also that integrate, I think with the kind of like the other, I think substrates or material, I think like or the components, I think I think that sounds like pretty relevant. I think if there are more data point that you can share, I think and I think that will be useful information to be covered here.
Sounds great. Yes, I'm making some notes, and I think at least we should have something more for the next time as well. Answering these questions. Yes.
Yeah, that's great. So we definitely look for more, I think, information, from you in the next meeting in 2 weeks. Then I think based on what you just kind of started sharing to us with that one slide.
Sounds great.
Great, appreciate that. Anyone else any comments? I think related to what Andrea had just shared.
So Andrea, do you see the need to have to delineate between 2.5D type rules and 3D rules? Are they totally different beasts, or you think we could kind of have a common set of rules to cover both?
No, that's a great question. I hope we can have a common set of rules, and probably the 2.5D could be a subset. But I think we should be able to theoretically, right, to encompass them with the 3D. I think that would be my guess.
Great.
Is that how you see it?
Well, you're the expert, so that's how I'd like to see it. But if you think it's feasible, that's what we should shoot for.
Got it.
So it sounds like in related to that question, so like maybe Andrew want to ask you to see I think there might be kind of many interchangeable in between 2.5D and 3D, right? I think there might be application that will use both kind of technologies at the same kind of implementation, right?
Yes. Exactly.
Okay. So that makes sense. I think probably could be or maybe treat that similarly that way then, so that there are people have option to use one versus another in the same kind of set, in the same set of the format structure.
I mean, that's right. Ideally, that would simplify. That's the thing, is kind of the trade-off between simplicity and kind of usability, as you know. Yeah.
Right. I think that's probably some challenge you might have to do and see. I think maybe first let's see what kind of data that we have, and we can kind of achieve both goals at the same time. That would be perfect. If not, then we can see how we structure that.
Sounds great.
Hey, Rudy, do you have any comments? You're also another RF expert on the line, and with respect to these rules, and also the other thing is, do you guys have, or could you create and provide some generic test cases that we can use to start building prototypes of these rules?
Let me see what I have available on our public site or near public site that I could potentially get on for those type of rules.
Great.
All right.
And even if you have real rules, you could just hack them and change the names just to obviate them.
As same as you, those
exactly,
real rules get into IP and protection of customers.
So we're aware of that. We can't
generic PDKs, ADKs. Yeah, let me see what we got that I could. That's on a near open forum. That I could potentially provide. All right.
Awesome. Thank you.
Okay. Because we have several ways to check them too. I mean, Andrea talked about one. We also have other ways with other tools. So, yeah.
Actually, we are interested in understanding that piece quite a bit. That once we have these rule sets defined, what tools on the EDA side will be able to support them? So
isn't that a premature question?
Well, this ties into MDK as well, the material design kits. So we do, in that working group, we have a lot of these materials and models that consume these material properties are somewhat proprietary type models. Imagine there's probably a similar thing that we're going to have to deal with, in the assembly rule, connectivity rules as well.
So there's one specific question in my mind, that is the final DRC checking of a system, multi-die system. So will the tools be able to do system level DRC, and how far are we with that capability?
Yeah,
I think there's a bit of a chicken and an egg situation here. First of all, how can we expect the EDA tools to go and build automation to do DRCs against a set of rules that we don't even know yet? We have to, first of all, define what type of rules it is that we want to standardize. We need to look at those rules from purely a data perspective, and then formulate the structure of how to contain and how to specify those rules. Only after that can you then expect the EDA vendors to be able to read and write to that specific format. Up to that, if we don't do it in that way, then what you'll end up having is multiple EDA vendors writing their own interpretation of what these rules are in their own interpretation of that format for those rules. And you will end up having invested a lot of IT cost in making those developments that those vendors will be reluctant to then standardize on afterwards. This is why various standard bodies try to put out, and IPC and IEC all do this, right? They try to put out a digital format, first of all, before the software tools have invested any money into developing structures to support that format, so that once that format is published, then everybody can work towards the same format. And if it needs enhancement, you enhance that particular one. In that way, you avoid this problem of multiple different formats coming on the market at the same time, all proprietary to the individuals who created that format.
So Michael, I think you're assuming that those tools don't exist today, and I'm not sure we know that. I think that was Jawad's question. Are there existing tools today that do DRC checking, for assembled devices?
Let's say the EDA vendors today, we help companies type out, release designs. So we both have solutions. It's not but again, it's headed down that path, like you mentioned, Michael. But if we can standardize and then maybe make it more standardized on how we define those rules, because we're both, I mean, it's inevitable, right? We're both helping people complete designs today. So we're doing it. But again, we'd like something a little bit more standardized under this, 3DK that we're defining. So that sounds great. I think what you described, Michael, is the right path to go. But I think in reality, let's just say we're both helping customers complete their designs today. It's just we're getting it done. You know what I mean? But it's maybe not elegant, but we're getting it done.
But I agree, Rudy, that that's life has to go on, so people have to go and develop tools to do that. But as a standards group here, we should step away from the tools and say, what is the right structure for defining the data? That's the ultimate goal, first of all. Only when you define that, then you then say, right, okay, what does it cost now to adhere to that structure? And if that cost is too big, do we go in and modify that structure to a lesser desired structure so that we can implement it inside in the tool simply because of cost? But that's a secondary decision, right? That's not a primary decision. The primary decision is define this purely on the aspects of the data integrity itself and nothing else.
Yeah. So Michael, one comment, and this actually came from Satish, and I wish he were here. So there's a strong demand from them on two things. One is, format standardization is great, but they want tools in hand, and they want some commitment that some tools will be supporting these formats. So I mean, it's a really big question, not very easy to answer. So that was my motivation in asking the question that, today we as designers hack something together and we basically tape designs out one way or the other. But it would be nice if there is a standard and then there is some clarity on who's supporting what and when and in what tool. I think that is what I understand was the main ask from Intel.
Yeah,
But-
that's a good point, Jawad. So I have had discussions on the Siemens side, and Siemens is committing to support these rules, and we're going to try to formalize that with the communication to Intel. Rudy, I'm not sure you were on that discussion, but we'd like to do the same with you. I think in principle, Cadence and Siemens have agreed to support these rules from an EDA perspective. We're still trying to get Synopsys into the loop. By de facto, they will be, through ANSYS, be involved in the MDK effort. In fact, I was on a joint call yesterday on a government program, and there was a Synopsys representative, and they were point blank asked, are you supporting these OCP 3DKs? And the response was, we see no reason why not to, but I think, in order to get Intel support, and in fact, support from the industry, we really need to have, the three major EDA vendors agree that we're going to support these. And if we start going off in different directions and pushing different formats, then we're just going to continue on this same old way where everybody's got their own standards, and then the poor customers need to deal with all the different formats. So that's what we're trying to do here. But I think from the big three, we need to make sure that we're all committed, and that was a specific ask from Intel. So if you could, Rudy, take that back to your management and let them know they are, looking for that level of commitment. We have an action to do that internally as well, and is Chris still on the phone?
Chris not in the phone.
Okay.
Understood.
No,
I'll take that action,
I'm sorry.
Tony. I'll
Yeah,
take that
man.
action.
Yeah,
I was on
Chris.
those calls, several of those calls. So
Yeah.
and congrats on your presentation. I thought it went well.
Thanks. Chris Rose, I think. Did he
No, Chris is not on the call.
leave us there? Mark Rose, I'm sorry. Mark.
Oh, you got Mark.
Oh, yeah,
Yeah.
Okay, sorry, did you have a question for me?
Yeah, we were just talking about getting commitments in support of the 3DKs from the major EDA vendors, and I know Synopsys was previously working with SI2. And do you have any visibility as to, whether or not they're going to be supporting CDX?
No, I don't know about that for sure.
Okay.
I mean, I was just in a few meetings that may be relevant here, because one thing we learned recently from Louis Paris at TSMC is that TSMC is interested in folding into their 3D blocks assembly specification some sort of assembly design rule specification also.
Mhm.
And I understand that they're working with Intel and considering the Intel specification as a good candidate for folding into 3D blocks. So if you're talking about trying to get EDA support for that specification, then if it's also going to become eventually part of 3D blocks, then that might lead to more incentive for EDA support from Synopsys also.
Yeah, I was aware of that. There that Intel is working directly with TSMC on that point. As we discussed earlier, I think one of the concerns that many of us share with 3D blocks, it is more of a kind of a design handoff to manufacturing type format, where it's really more of a static snapshot of your final design, whereas what we're trying to do with these formats, it is a living, breathing format that's used during the design planning and implementation process. And then once the design is ready to be signed off, they can readily create those static snapshots. And there's things like material design properties and some of these advanced packaging rules, which live outside of the silicon world, really are not being addressed by 3D blocks. So we view largely what we're doing is kind of broader in scope and use than 3D blocks. And based on that, we think we can readily create the 3D blocks formats, and just because that is going to be a requirement. But in working with several other foundries, there's been quite a bit of reluctance in adopting 3D blocks, just because it may not support their specific needs of their foundries, and they're not even dealing with OSAT and substrate type rules either, at least that I'm aware of.
Yeah, I see.
And they're they support wafer sort test, but it is pretty specific to TSMC's the way they do it, and it may not be generally applicable. So that's why there's certainly a lot of overlap, but and again, it's really not they did open it up, but it is kind of a specific vendor-driven format that they're trying to get the rest of the industry to adopt. So I think it's a little better than just just saying this is our format, use it. They did open it up, and they are collaborating with the EDA vendors. But I think again, it's not addressing all the things that we're looking at in OCP.
Oh yeah, I certainly agree with all of your OCP 3DK, all the materials design kit work and the other work. I think the TSMC interest now is on that small subset of assembly design rules, and like you said, it's not even the full assembly set of rules, because it leaves out certain things that OCP is going to address. I agree.
Right. So in principle, I think there should be alignment where there are common things where they're compatible. Maybe it's a different language, but I think language is not a big deal, whether it's YAML or CDMXL. It's really the contents that I think we need to make sure are interoperable. But again, functionality and scope, I think we're looking at a much broader offering than what TSMC is considering today.
Mm-hmm.
So along the same lines, Tony, that you were mentioning, I actually want to ask a question to folks from HRL, and you guys are manufacturers. What is your opinion of 3D blocks format? Have you looked at it?
Oh yeah, I mean, we're supporting it. I mean, if you're an EDA vendor, you are supporting Intel, and by definition, you have to support 3D blocks. So we are supporting it, because we have to. It's a requirement from TSMC. But my vision is that we will have formats that can readily create a 3D blocks format that can be delivered to TSMC when it's required. So I think that's got to be considered when we're doing these formats. We need to make sure that whatever we do, we can readily, I think translation. I'm hoping that it can be a simple translation. So that's something that the major EDA vendors are actively working with TSMC. So we're familiar with these formats. So if we find issues and compatibility issues with the stuff that we're doing, that is a discussion we'll need to have, and that may kind of not cause us to, it may just require some modifications just to make sure there is no path to that translation without going through major hurdles.
Okay, so Tony, but at the same time, another question. So EDA support of 3D blocks is well understood, but are other manufacturers, say in United States, like HRL, do they have access to 3D blocks, and can they make use of it? Or
I can't answer, but I can speak for Samsung, and there's another new fab being brought up in Japan. They have flat out, said they are not supporting 3D blocks, so they are looking for another standard. So they're very interested in supporting what we're doing here.
So I think that's the big answer then, especially in United States with all the CHIPS activity. Some kind of a collaborative model is better than purely competitive, right?
Right. Even if 3D blocks was 100% met all their needs and did everything that we're doing and could support the scope of what we're trying to do, I think there would still be reluctance if it was a TSMC open standard format. So I'm not saying there would be reluctance. I'm not saying it's not impossible, but right now, from what we've seen, is there are some showstopper issues, and getting those additional features and needs in there. I'm not sure those other boundaries and OSATs would be open and willing to provide those requirements. So Andrea, I'm assuming you're probably not aware of working with TSMC on 3D blocks, but correct me if I'm wrong.
Yeah, so we're vaguely familiar with 3D blocks. I guess from our point of view, is we're more of a niche, industrial application. If any, it's not the same sort of, I guess, pull or seat at the table, however you're gonna call it. But from our point of view, there is kind of a nice investment coming from from DARPA, as you know. I'm sure you're all familiar with, and so really that's kind of our motivation here, is to make sure that we don't miss a chance to do better as far as interoperability, which is really what we're after, and I hope everyone sees the value in that. Yeah.
Right. So I'm not aware, and if anybody else on the call is aware, I'm not aware that TSMC is providing any support capabilities or manufacturing of these type 3.5 material properties. So I suspect they would not be accommodating any of the needs that we've been talking about for most of today to be able to support these types of gas scan structures and rules.
Exactly. I think the way I see it is whatever we do, we would have to almost like encompass. If we want to make it compatible, we would have to encompass what they're doing, I guess, and maybe ideally, I guess make it better, not better, but bigger or more, a farther reach, I guess, and as much as we can.
Yeah. So the scope, really, that's another dimension of the scope. It's the technology, right?
Exactly.
It's the usage, and then the you know,
That's exactly right. And it flows
Yeah.
right back to, through the ADA chain, all the way from tools to, to verification. Absolutely.
yeah. Okay. Okay. I mean, I think what we're doing is important. I think we always need to revisit that to make sure we're not, reinventing the wheel for something that already exists. But I still feel pretty strongly what we're doing is broader in scope, and there is a need for that. And we have immediate needs with some of the DARPA work, but even just for the broader industry, I think it's important that we take a broader scope in what we're doing here.
I totally agree.
Cool.
Yeah, that's good discussion over there. I think I'm glad. I think we have a lot more synergy here. I think hopefully I think next time I think I will have more perspective. I think from Angel, I think from that look at, I think also probably I think from Rudy and see what from the cadence side any kind of the rules I think that use in some existing tools can be share and talk about here as well. And then we will continue to ping on the Intel and with Satish and Chris, and hopefully they will be able to respond by before next meeting. And also the SE Roger, I think he's traveling to Taiwan. I think until end of the month, and hopefully I think next meeting will be February 1st. I think hopefully he might be back by then, and see we can ping him and see what we can hear from him on the SC side. I think the type of rules from the assembler side. Yeah, meanwhile, I think quickly continue from this what we have from last time. I think we talk about starting from silicon proposal, we expanding based on what we have and just kind of put in the placeholders, kind of the overall kind of structure rules that we be meeting. I think distance, dimension, diameter, area, density, even ratio. I think we talk about some of these things, and then we can continue to expand a bit on this kind of dimension, like what kind of alignments, clearance and things like that. I just kind of push placeholder while we're waiting for more data points from those you mentioned earlier, right? From the Intel, SC, and also from the HIL, and then we'll continue to expanding from data and do that in the parallel efforts. Yeah, I think that's probably all what we have. We almost on the time here, only a few minutes left. Anyone have any other question or any other points that want to bring up here?
Yes, James, I have a few organizational questions.
Okay.
So, mainly geared towards you, David, and Tony. So, we need to come up with some kind of a plan to understand the need and the request from Intel in some actionable manner, right? So that we have some timeline in front of us that, when are they going to, how are they going to engage? When are they going to give us the design rules? All the high level meetings with OCP, they all happen already. So, the page that you are showing, we will very quickly start adding to it. And it can, I can clearly see middle of the year, end of the year, this goes to an OCP contribution, right? And we should inform Intel what our timelines are. So whatever processes they have to do, they get an idea that, we are working with some timelines in the mind. We are not under any strict deadline here, but I think we cannot just keep this open-ended, right?
Well, Joel, just to comment to that point, there is a compelling need to have a working prototype by like the July timeframe, based on some of these DARPA programs. So I think it really is important that we get a baseline in place. It doesn't have to be final. It doesn't have to be standard, but in some of these programs, these 3DKs are an important component of that, and that work will begin kind of in that time frame, Q3 time frame, and we really need to have at least a baseline of capability. And as we go through that exercise, I'm sure we'll be fleshing out a lot of the stuff. And these programs do require this Type 3.5 material rules as well.
Yeah.
And then we're going to have to do test also. So I'm a little bit concerned that test is a huge effort, and that's probably something, I hate to add yet another biweekly meeting, but I don't know if we can do these things in parallel. So we may want to consider. I thought maybe even in lieu of maybe we have the CDX proper meeting, every other week, and then we use that one of those time slots for a test meeting.
Yeah. But we should tell this timeline to Satish, right? This is a timeline in our mind.
Yeah, I could do that. I'll be happy to do that. Right. The other thing I did want to mention is that Keysight has gotten back to me, and they are definitely interested in the MDKs, but I think we should invite them to the ADKs as well. So we're just due to the end of the year and stuff. They haven't figured it out, but so they definitely want to participate with us on this effort. So I think that'll be good. We started out with no support, and now we've got several companies managing this stuff, and that really is something DARPA is looking to advance the technology to deal with the integration, and specifically the program and GMM is looking at 3D integration, but there's also 2D, 2.5D as well. So they're bought into what we're doing here, and but we're going to have to deliver.
Of course.
Yeah. So we had, I think it's actually Satish also brought up the need for or suggestion of having a open source tool that would be not coming from any EDA vendor to be able to kind of author these rules, rather than just someone sitting down writing XML or, so just something with a GUI and some built-in smarts that would make it easier to organize and create these rules. And I think we may have an opportunity in these DARPA programs, and there's other programs as well in the government. There's Commons Hub. We may be able to propose that perhaps a university could, provide resources to develop that tool, or potentially, fund a non-super EDA vendor to develop this tool. So that is something that I think maybe Rudy, you and I can kind of brainstorm on that a little bit and try to see if we can squeeze that in there. I don't think it's a huge effort. But
Tony, have a standards body create that tool, because NIST has been talking about as
do
part
they have
of
the resources to do that?
Well, it depends on the standards body. They might be able to, especially if they get the funding from the government to help create that type of tool. Yes, then yeah, that might be an opportunity to do that.
All right. Yeah, maybe Michael, if you could take an action just to see if it's feasible. I did talk to Jawad and Bapi, and it doesn't look like there is a path to do that in OCP to get funding. They have no mechanism. And Mark, I don't know if SI2 is that something that could be done in SI2, and is that something you guys might be interested?
Perhaps. I know Satish did talk to us about it also.
Okay.
It's not something that we've made any decisions about.
But I mean, is it structurally feasible?
Yes, it's structurally feasible. Yes.
Okay. So let's talk on that. Maybe we could set up a call with Satish to see if that's something. And we've got the the connections in with the government agencies where we can put a proposal to them to see if they'd be open to putting some funding into that. I suspect there is. I don't see it as a huge cost, relatively speaking, to the amount of money they're spending. CHIPS Act is 50 billion, or so. But again, I think rather than having each EDA vendor having their own little front end GUI built into their system, having a true neutral thing, I think that would kind of be within the spirit of what we're trying to do with these open standards.
Mm-hmm.
Okay, we're over. So thanks everyone.
Yeah, I'll put that in the notes. So okay, thanks everyone. I think we'll do follow up with Intel and everyone. Yeah.
Okay. Bye, folks.
Thanks. Yeah.
Thank you.
Bye everyone.
Bye.
Bye.
Yeah. Drop off. Okay.